Everybody, welcome to this week's online class. It's nice to see all of you guys all connected here. This is, I think, the largest group of connections I've had so far in online classes, so that's fantastic. I just actually got off, I did an online interview with a former student, an alumni of computer science, and I'm actually going to start today's class by sharing my screen and showing you I sent out an email actually just a few seconds before today's online class. And on the student alumni page of our website is, I sent you one of the videos to help motivate you guys. And you guys are all already pretty motivated by connecting today. But I've created a series of alumni videos for you guys to watch where these students, former students who took computer science with me, will tell you reasons why it's a good idea to keep going. The one I recorded just this morning, I interviewed this student, Zach Havens, actually works out of Google in New York City, right downtown Manhattan. And that's where he is in the video on the roof of his apartment building where he's working from home. And you can watch that video and then the two other videos which were recorded by the students themselves. And I actually sent you this first one today in an email to keep you motivated, to keep you on task. So today's agenda is outlined on our class website. And what I'm going to do today during this video is, here we are, week 12. Happy Star Wars Day, everybody. It's May the 4th today. So May the 4th be with you. Today, what I want to do is work on looping part 1. Okay. And what I mean by work on looping part 1 is I want to go through the first 2 assessments of the looping unit, looping assessment 1 and looping assessment 2. The same way I've been going week by week. Now, what I would recommend for you if you're ready to start looping is to open up the looping folder, which the link is right there on the website. So you can see all the content of the looping unit. So you could look at the PowerPoint presentation. You could go into the hints. You could try the code through the demonstrations, right? I would definitely recommend you watch the looping video of part 1, where I taught the lesson in class and live in front of students, including the example. That's all there for you. You could also read through the PowerPoint notes of looping part 1 to get an idea about the content of what looping is and how it works. So those are definitely things that you should do if you want to learn looping in any great detail. Then when you go to start the assignments, I would recommend you try the first example, or at least look through the code of the first example, where you'll get your idea of what a loop looks like in terms of the way it works in code. Now, I've incorporated this loop into other code that we've already done, things like random numbers, and even some new stuff like how to use a list box, which is included in part 1. Then you could have the hints open, which will give you hints on how to start working on looping if you are working on the assessments. And then you would go and dive into the first 2 looping problems, which is what I'm going to do with you guys today. I'm going to go obviously at a pretty fast pace, but I am recording this so that I am recording it, right? Let's just check. Yes, I am. So that you can always go back on the video and go through that, which I know a lot of you have been doing to get through some of the looping work, okay? So this is all stuff available to you. I'm just going to close a few of these tabs to try and speed a few things up here, okay? I'm not going to go through the case study because case studies are already laid out in a way that you can go through them at your own pace. Everything you need to do a case study is laid out right in the case study itself. And then I am going to go through looping problem 1, the how to be a millionaire problem, and then looping problem 2, the Lotto 649 problem. I will also show how I would do these problems if I was doing the alternative versions of these assignments. So right off the alternatives assessment page and keying it in right here on the web. But let's start with looping problem 1. Okay, so in this one, you can see how it looks and how it's going to calculate how many years it's going to take to become a millionaire using 7% interest every year. That's what annually means. It's a bit of a math type problem. There's a little bit of math knowledge that's needed for this, but the real key to this is for it to keep looping and doing the calculation over and over and over again. All right, so I've already built the design here, and let's take care of some of the easy stuff first, things like the exit button. And you've seen this before, so if nothing else, you can always take care of easy stuff first. Exit this program, okay? It's the application, whoops. And why don't I also take care of the reset button right now? Because let's think, what would reset do? It would take my text box and set it to nothing, okay? In other words, clear out the text box. Now, I hope this is a little bit easier. This was obviously something that took a little thinking and a little sort of working with the code back in the variables unit, but now having done this for a while, I can probably explain that a lot quicker. The label I have that has how many years in it, not the one with the info. The info one is just this one right here. I don't need to do anything with that label, but same thing. The text of that label will also be cleared out. So I'm going to clear the label. But I'm going to add one other line of code. This would be something new. This is not actually something that you would need to do, but I think it would be kind of cool to teach you something new here. I'm going to take that text box and I'm going to use a line called focus. I'm going to show you what that line does right here real quick. What focus is said to do is drive what's called the focus of control of a program to a specific area. It's something you probably experience a lot as a program user, but it's much easier to sort of explain it by actually doing it. So right now, the focus of this program before I do anything is the text box. That's why that little cursor is flashing in it. If I hit exit, I just switch the focus over to the exit button, which then shut the program down. If I was to click this button, it would have transferred focus to this button. Notice there's no longer a cursor in that text box. So if I was going to type in that text box, I would have to click on it first, and then focus would go back to that text box. When I hit reset, it cleared this, and put the cursor or the focus back into that little text box. So it's just something fun to try with this problem. But the main gist of this problem all comes from this button, how many years to be a millionaire? Okay. In order to do this, the first thing I need to do is get the text from the text box. And I'm going to convert that into a number. Number represents the balance of the account, which is money, represents money, okay? Now, normally when we do this, we can do this in two steps. We'd do like this. We have a value equals txt balance dot text. That reads the text out of the text box. Then I would make a double for like the balance. I'm going to use double because it's money, so I can use decimals. Equals convert dot to double of that value. And there's nothing wrong with this code. This is very good code. But we're going to kick it up a notch as well. Again, this is something that's covered a little bit in the looping code. Now that you're getting a little more comfortable with code, what I could do is do this in one step by actually taking the text of the text box, placing it right here, so that it reads the text out of the text box and then converts it to a double. And that's a way I could do it and avoid that second line of code. Nothing wrong with this. Oops. Wrong with this way by using it string and then that way. But we're going to try to sort of shorten it a little bit here, jumping it up a little bit in the way we do it here. Okay. Now, I need a variable to track the years. Years is a whole number. So I'm going to make an integer. Oops. Let's try that again. Called years and set it to 0. So 0 years. constants that do not change. So for example, a million is a number I'm going to represent as a 1 and 6 zeros. 1, 2, 3, 4, 5, 6. And even the decimal if I want, because it's money, right? So that's $1 million. I'm also a constant double to represent the interest rate, which is 7%. But to represent 7% as a number, I have to, do that. You got to be careful with this one. A lot of students put 0.7, that's 70%. So we got to kind of be careful with that. All right. Now the key part of this problem, the part that actually requires me to use a loop. Okay, and the word that we learned in looping is the word while. While the balance, how much money they have, is less than $1 million, the loop will keep going. So a loop, like an if statement, uses both round brackets and curly brackets. It also, like an if statement, uses a true, false test, and it keeps going like an if statement while it's true. But unlike an if statement that works once, the loop, when it gets down to this curly bracket, goes back and checks it again, and then does the inside part of the code if it's true, and then it goes back and checks it again, creating a roundy, loopy structure here where it keeps going over and over and over again. Okay, so let's figure out how much interest, or we're going to calculate how much current interest. So make a double for the interest equals. Now you might think, well, I already have something called interest. Yes, but I used all capitals up here, and I'm using all lowercase down here. So I can take the balance and multiply it by the interest. That will calculate how much interest they have. Okay, now I'm going to add that onto the balance, because now their balance goes up. So their balance equals, balance was, plus this interest that we just calculated. Okay, so I can do that. If you want, you could consolidate these two lines of code into one line if you wanted to. I'll just show you what that would look like by just doing this right here. Okay, so you could kind of do both of those things at once if you wanted to. This would be a way you could do it. You could say, okay, I'm going to take the balance, multiply it by the interest, and then add it onto the balance. Okay, you could certainly do that. But I kind of like it in two steps here. So, and then this counts as 1 year, because every year this happens. So the number of years I have equals the number of years I have plus 1. It goes up by 1. So I add 1 to the number of years I have. Okay, my balance goes up by the interest, and the years goes up by 1. So that's all happening inside this loop. Get rid of some of these extra spaces. We have more of that at once. There we go. Okay, so within this loop, that's what's happening. Okay, I'm just going to pull back a bit so you can see a little more of the code at once here. So inside this calculate button, I got the balance out of the text box, created a variable to track the years, created a couple constants for my calculations, created a loop, calculated the interest, calculated the balance, calculated the years. The final thing I need to do is show the results in the label. Oh, my label, LBL years dot text equals. So we're going to have some words, and here I'm going to jump over again to the way it's described right here. Okay, so it'll be the word in and then our number. Okay, so in with a space, how many years, and then I'll say you will become a millionaire. You will become a millionaire. Let's put this to the test. Okay, so I've got all the code for this calculate button, all placed inside the calculate button. Let's see if it actually works. And what I'm going to do is I'm going to test it with the number 100, and I should get the number 137 if my math is correct. Uh-oh, what's wrong? Did I miss? I missed a semicolon. No. Amateur. All right. There we go. In 137 years, you will become a millionaire. 1,000 in 103 years. 100,000 in 35 years. Okay, so that works. However, the other thing I would want to do is make sure it works with all these numbers. So 1 penny, would it work with 1 penny, which is the smallest amount of money I could have? Let's see, 0.01. Yes, 273 years. But then I did 100, I've done that. But what about when it goes over a million? What about when it's 0? And what about when it's a negative number? I actually know right now that that will probably crash the program, because that's not going to work right now for what we have here. So one thing I'm going to do is I am, right after I read this, going to make a double check. I'm going to check the balance. I'm going to add a little code here. So right at the top of this calculate button, right after I first read the balance, I'm going to check it. If the balance is less than or equal to 0, well, what I'm going to do is just go right into that label, and I'm just going to put some words right there. You will never be. Because there's no way you can get interest off of $0 or negative dollars. Trust me, I know. Now, what about else if the balance is greater than or already equal to $1 million? So this would be a good opportunity for me to do this before this. So I'm going to move this piece of code up. Before $1 million. So now I'm going to change the label to say you are already a millionaire. So I've checked to see if it's less than 0, checked to see if it's greater than or equal to $1 million, and then I'm just going to put an else, open the bracket here, put all this code that I already have inside that else. So in other words, that else ends right here. Let me pull back so you can kind of see now this in more detail. I'm going to back up. All right, here we go. So the calculate button gets the text from the text box, converts it to a number representing the balance. Here's some constants that don't change for million and interest. If the balance is less than 0, if the balance is greater than or equal to $1 million, I will change what it says inside the label. Else, I will create a variable for the years, a loop while the balance is less than $1 million, calculate it that way, and then show the results in the label. And now, trying this out one more time. Now, if I put $0 in here, it does say you'll never be a millionaire. If I put a number bigger than $1 million, you're already a millionaire. So this is now a much more error-free program using the if statements that we learned in the last unit and this new concept of the loop. Okay, so you can go back and rewatch that. And if this has been confusing, again, please watch and read some of the content of looping. What I'm going to do now is I'm going to go in to the alternative version of this assignment for those who are doing it that way. And I'm going to, oops, that's variables, jumping through conditionals over to looping. Here we go. And you can see it's the same basic problem, just a little bit simpler. You just have to enter it, and then it just sort of works off that. So I'm going to use a lot of the code that I put in this one, but alter it for here, okay? All right. Also, for those of you who are on the line right now, please let me know if you need, if you have a question, just go ahead and yell it out as I'm working through this. Otherwise, you can quietly watch as I do this. So we're going to enter our account balance. Okay. Now, because this version of C# Online doesn't have a design element to it, you have to use the console and read the line from there and write a line out. Okay, then the balance equals convert dot to a double. So I can't really do the steps in one there because we got that. But then a lot of the code will start to be the same. So once I have the balance, just like I did here, I'm still going to need constants. I'm still going to need if statements, else statements, and loops. The only part that's going to change is the label part. But I can steal a lot of this code just to save myself some time here. Okay, I have to indent it back, but there we go. So I'm still going to have constants. I'm still going to check the balance, but instead of putting it in a label, I'm going to put it into the console and write line. You will never be a millionaire. And same with right here. I will put it into the console and just write that line out. You are already a millionaire. Still will have the variable to track the years, still will have the loop. The calculations are the same. Again, the only difference down here is I won't be using a label. I'll be just using console.writeLine right here. So let's try this program and see if it works. Okay, I'm gonna run it, enter my account balance, 100, and that's annoying. There we go. 137 years, you'll be a millionaire. That worked good. If I run it and put in 0, you'll never be a millionaire. If I run it and put in 2 million, oops, I didn't put in 2 million. Too few zeros. What happened there? You're already a millionaire. So it works just dandy here in the alternative version of the same code. The big difference would be switching from a design to the console code, and that would be available. All right, that takes care of the first looping problem. That's everything you would need to know on how to solve this problem. A great way to engage in your online learning is to go through that problem and solve it. Now, you don't have to follow mine. There are other ways you could do it, but that's my suggestions for problem 1. Now moving on to problem 2. This is the Lotto 649 Millionaires problem, which makes use of loops, a few loops, and something called a list box and a combo box, which is new. Okay, so those are some new design elements that you'll be putting into that one. So that takes care of looping problem 1. Okay, also don't forget your comments in your code. And now on to looping problem 2. Okay, not much to code here, just one button, a draw button, which we're going to put in. But there is one other thing we're going to code in looping problem 1, and that's form load. So find a small empty spot on the form and double click that for the form load code. Okay, why I'm going to use form load is I'm going to use this to put some values in the combo box. Put is spelled. So this is what's called a combo box. You've seen it as a user. It's a little drop-down box where things can go. And the way it works is you put the name of the combo box, dot items, and then another dot, and you're going to say add. Instead of an equal sign, you're going to use round brackets, and inside of there, you can put what you want to add into that box. So I'm just going to say a 1, and then I'm going to do it again, and I'm going to put a 10, and then again, and 100, and again, and 1,000, and one last one, 10,000. Okay. Combo boxes can also be like text boxes. You can say dot text. You can put something in there. I'll just do this for a second, just to show you how it works. And this is going to be important because this is also going to come up with the list boxes the same way. So here you can see something is in the combo box, but if I drop it down, there's the things I added to it. Okay, so just like that. What I'm actually going to do instead of the word something is I'm also just going to put a 1 there. Okay, that way it's the same thing in the text area as would be in the combo drop down. So the 1 is always there. I can switch it, or I can go back that way. Okay, so it was in this looping unit that I introduced the idea of the combo boxes as a new thing to work on. So that's what those are. All right, now back to the draw button. This is where all the code really happens. Okay, I'm first going to start by clearing out the list box for any, I can use the word subsequent, which means anytime after the first time runs of the program. So the list box will fill up with lotto numbers, but if I keep clicking draw, I want to clear it out first. So I put the name of my list box, LST numbers, dot items, dot clear. And that's all you need to do. It clears the list box out. It's as simple as it can be. Okay. Now, the way this problem works is I have to generate a random number. So if I'm working with random numbers, I'm going to need the good old random equals new random. This is how you create a random number generator. Okay. So I'm going to create a generator for random numbers. Okay. So in a way, this word right here could be something like generator. That would be kind of cool to generate it that way. But I'm just going to stick to what we've already learned. Random equals new random. I think that makes a little more sense. Okay. Now, how many draws should they do? Well, the number of draws comes from me converting to an integer what's in the combo box, the text area of the combo box. So this is very much like we did in the previous program. I'm going to get the text from the combo box and convert it. One step. I converted it in one. If you're not comfortable with that, you could do this in 2 steps by putting something like string value. Whoops. Equals this thing. And then I convert the value right here. That would also work. That's 2 steps of me doing it. But I'm going to do this all in 1 step just to keep it nice there. Now, yes, if draws is less than or equal to 0, then I can't do anything. Like I can't do 0 draws. So maybe I'll put up a message box. I have any labels here, and I'll show enter more than 1. Something like that. Otherwise, now I can do something. Now they've entered a draw like 1 or something. So in a way, I had to check the draws. Now I'm going to be doing a loop. So I'm going to need a variable for looping. Okay. So not to be too confusing, but I'm going to make one just called draw, which is the current draw, equals 0. Okay, and now comes my loop. While, scroll up here, draw, which is 0, is less than draws, which is the total number of draws, I'm going to keep looping over and over and over again and doing something inside this list box. For now, let's test that. Let's add content to the list box. So like we did with the combo box, list box dot items dot add, and for now I'm just going to put the word test. Okay. However, I also need to increase the draw by 1. So the draw equals the draw plus 1. Or for this problem, I'm going to try a little bit of shorthand. This line of code means, and I'll put this in a comment beside it. And again, if you're not comfortable, don't do it. This means draw equals draw plus 1. It's just shorthand for the same thing. That's what this means. Okay, it means the same thing as that. Okay, so I'm just going to give this a whirl. Let's see what happens here. So let's say I want just one draw. You can see the word test appeared once here. But if I want 10 draws, the word test should appear 10 times here. If I went 10,000, then that word should appear, takes a second to process it, 10,000 times inside that box. There it is, 10,000 times. Okay, so that's how it's going to work, okay, to do this. Now, it's not solved yet, but that's me using a variable called draws with an S and draw with a no S. And while that one, which is 0, is less than the other one, which I got from the text box, it'll keep doing it and adding 1 to it each time. Okay, now what I actually need to do in the loop is generate 6 random numbers. First one is really easy. Number 1, I'm going to keep it simple, equals random dot next 1 and 49, but I always go 1 more than 49. That's the way random numbers work. It's a random number between 1 and 1 less than this one. That number 1, I'm now going to place inside of my items here. I'm going to just attach number 1 right here, just to see how that works now. Let's see if it's generating a bunch of different random numbers. There we go. There's some numbers there. Okay. All right. Now, what you'd think is the next number is going to be just as easy. N2 is done the same way. So now when I go to this list box, the way I'm actually going to do it is I'm going to say, here's N1 plus a comma, which is in quotes, plus N2. And you can see I would just be able to do this with all 6 numbers to do it this way. Let's try it. And I'll do 100 of them. I'm going to do 100 numbers, 2 at a time. And there they go. But what I hope I can see here in a second, if I scroll through this list, it's possible. It's not likely, but it is possible. Not sure if it will show up in this list or not. The 100 numbers, I'm not seeing it. I don't think it happened. Let's try again. And again. Okay. It's possible that I would get the same number. That, let's say, it generated an 8, and then it generated another 8. And that can't happen. They have to be different. So starting with the second, use a loop to make sure the numbers are, and I'll use the word distinct, which means they're different from one another. So the way I do it is I generate that second number, but then while n2 equals n1, while they're the same, do it again. So I'm going to repeat this line of code. I don't have to repeat the int part right there. So it keeps looping while they're the same, over and over and over again. The second they're not the same, it just moves on with the code. Now, your thought may have been, why don't I just use an if statement, if they're the same? Well, that would work, but only once. And it's possible that it would still generate, like let's say this generated a 7 right here, and then this generated a 7. If n2, 7 equals n1, 7, do it again. But what if it generated a 7? The computer's not smart. What if it just kept generating a 7? It would then go on with the code. But if I put this as a while right here, it would go back and check it again. Oh, it's still 7? Go back and do it again. Oh, it's still 7? Finally, when it made something different, then it would move on with the code. So that's why a loop is a better structure here for doing this. Now, with that as our template, let's now go on and make the third number. N3 equals a random number. While N3 equals N1, but wait a minute, I got more to check. And N3 equals, and actually it wouldn't be and, it would be, as I said right there, or N3 equals N2. So well, 3 equals 1 or 3 equals 2. And I'm just going to move it down a line here so that they line up. Well, 3 equals 1 or 3 equals 2, and 3 equals a random number. And then I'm just going to incorporate it into this right here. I'm going to say another comma, and then here's N3. All right, let's kind of see where that goes right now. This is a bigger problem, so it's a little more work. Generate 100 of them. So as you can see, it's generating 3 random numbers that for sure aren't ever the same. So 41, a 44, and a 25. Now it's possible that this set of numbers might match the set of numbers up here. You don't need to worry about that. It's just that within each set of numbers, no 2 numbers can be the same. Okay. All right, and then we would keep going. So now I'm going to do N4. So if N4 equals N1 or N2, remake N4. But now I need to say or, oops, N4 equals N3. I have to also check it against N3. And then I'm going to do it again. N5. 5 equals 1, 5 equals 2, 5 equals 3, remake 5. Or N5 equals N4. Definitely a harder problem here. And then one more to go. This will be the longest one. N6, the 6th random number. If 6 equals 1, 2, 3, or 4, remake 6, and also check it, or if N6 equals N5. In a second, I'll back up and show you all this code. There it is. There's all that code. Get rid of a few of those extra spaces. And I'll go back and zoom in on it in a second, but let me just see how it works. This is a tougher problem for sure. This is a tougher unit in terms of the code for sure. But I'm going to do 1,000 random numbers. And I have forgotten to add them to the list box. So let's do that. This way too to space it out. 4, and 5, and 6. So there's the 6 numbers separated with commas. Let's try this again. 1,000 Lotto 649 numbers. And there they are, randomly generated. Oh, it's a little crowded. Let's shrink that font size down a little bit so we can see it. A little design issue here. Here we go. Let's try that again. All right, 1,000 numbers. There we go. 1,000 Lotto 649 numbers. And in each set of numbers, there will be no duplicates. So you can see that, right? No duplicates in each set. And that's how you solve that problem. A tough problem, a tough one to solve. Let's review that code before I take it over to the alternative assignment. So when I click the draw button, clear out the list box in case this is the second or third time you're running this. If it's the first time, obviously you don't need to because it's already cleared out, but that just is helpful. Create the random generator for random numbers. Get the text from the text box, in this case the combo box. Convert it into an integer for the number of draws. Check it. If it's 0, yell at them. Otherwise, create a different variable for the looping. Use a loop while draw is less than draws. Generate your first random number. That's easy. But then starting on the second one, make sure it's different than the first one using a while loop. And if it is, generate it again. By the third, fourth, fifth, and sixth number, not only do you have to generate it, but you have to check to see if the sixth one equals the first one, or the second, or the third, fourth, or fifth. And then you put all 6 random numbers into the combo box, separated by commas. Finally, as you're at the bottom of the loop, increase the loop draw variable by 1, so it goes back up to the top of the loop and goes again until it's finally greater than the number of draws, and then the loop would stop. Okay, we also had a little bit of code in form load for that to work. All right, final thing to work on today would be then adapting that into this version of it. So it's got a lot of the similar type of code there. So I'm going to, make a duplicate of this. And I'm going to have the user, as it says here, enter the number of draws. Okay, oops. And value of this, actually you could do this all in one line. Let's be a little bit creative here. Int draws equals convert to an integer. Oops, put a capital C on convert. Console dot read line. So I read the line and convert it to an integer. Okay. Then my code would be very similar, right? So it would be very similar to what I did up here. Okay. I would still need to create a random number generator. But one thing that this online thing may not do, I think it'll be okay. So we'll just leave that. All right. Then I would check the draws. I wouldn't have the ability to do a message box, so I'll fix that in a minute and do all this, which would be the same. And I wouldn't have a list box, so I'll change that in a second. But other than that, the code would be similar. So I'm going to place that code in there. But instead of doing a message box, I would do a console write line saying enter more than one draw. I would still have my variable, I would still have my while loop, I would still have all this. But instead of a list box, I would just write, and I'll put a little bit of words here like it shows in the assignment. I would have draw 1, 2 like that. So I'm going to say the word draw, and I'm going to put my draw variable. I'm also going to switch the order here. I'm going to do this line after this line, just so that it doesn't say draw 0. It automatically starts at draw 1. And then have okay, so let's see. That's would be the same kind of code. The big difference would be up here where I enter the number of draws and read it in using the console. And I would use a console for the message box. And then obviously this line down here would also be very different when I do a write line instead of that. But let's try it. Let's see if it works. So I'm going to do 10 draws. And oops, there they are. There are my 10 draws of 10 random lotto numbers. Let's try it again with a bigger number. Let's try 50. And you'd have to scroll, but there is all 50 lotto numbers all drawn out there. Well, kids, that would conclude how to do problem 1 and problem 2 of the looping unit, which was our goal today. So here for Star Wars Day, May 4th, to complete looping assignment 1 and 2, which is awesome. I will be posting this video shortly. On tap for next week, the midweek May, I'm going to look at part 2 of the looping unit, including the alternative assignments, which will take us right to the end of the looping unit, which is pretty cool, which means by the 3rd week of May, which you can see right here, we're going to go over some programming extras, which is going to be some cool gaming type stuff to get ready for a final assessment, finishing up the looping unit. All right, everybody, I'm going to stop sharing here. And before I wrap up, if anyone has any questions, just let me know right now. If not, you feel free to email me anytime you'd like. I hope you enjoyed today's online class. I'm going to wrap it up here in a second. Take a look at that email I sent you guys and take a look at that alumni video that I sent you to get some motivation, if you'd like that motivation as to why to study computer science and why you should keep going. Okay, everybody, that's it for this week. See you next week. Email me anytime you have any questions. Bye, guys.
Thank you. Thank you. Thank you.
Thank you.
Guys? Oh.